Many of us have probably learned in either elementary or junior high that if you want to know if a number is divisible by 3, you just need to add up the digits of that number, sum them up, and if the resulting sum is divisible by 3, then that initial number is also divisible by 3. So for example, you have the number 51, right? Is 51 divisible by 3? Well, add up the digits. 5 plus 1 is equal to 6. 6 is divisible by 3. Oh, therefore 51 is divisible by 3. And that's just an existential example. 3 times 17 is 51. Okay, well, let me just write it out in English. So actually, no, let me not do that. Let me just do this. Let n, being a positive integer, equal to dn, and then dot, 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 d1, d0. Okay, so I'm just listing out the digits in order. So something like 5, 1, 2, 4, 3. Okay, this is just an example, okay? There's n plus 1 digits, okay, because we have d0. But if we want to write this out using powers of 10, it's going to be dn 10 to the power of n plus, and then dn minus 1, 10 to the power of n minus 1 plus dot, 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 plus d1, 10 to the power of 1 plus d0. Okay, that's my constant, but I could do 10 to the power of 0. Okay, 10 to the power of 0 is equal to 1. Okay, this is place values. Okay, you have the ones place, the tens place, the hundreds place, etc. All right, and if I really want to write this out in compact notation using sigma, I can say this is sigma sum k equals to 0 to n of d sub k 10 to the power of k. Okay, where k ranges from 0 to n, and it has to be greater than or equal to 0, okay? Or I would say n is an element of the whole numbers, where whole numbers is the set of non-negative integers. Okay, so the theorem is, so let dk, your digits, okay, dk is just a digit, being in the set from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, we have 10 digits, from 0 to 9. Then 3 divides into n, which I call this sum right over here. Just copy and paste that. If and only if, so it's both directions, it's biconditional. 3 divides into the sum of the digits. So it's just sigma, and then, yeah, the sum of the digits. Okay, so it's biconditional. All right. So earlier, we had the 51, right? So because 5 plus 1 is equal to 6, 3 divides into 6, therefore 3 divides into 51. But if I know that 3 divides into 51, then I can conclude that 3 also divides into 6, which I find really cool. Right? We learned this in grade school, but the proof really wasn't given to us at all. So the proof is really nice. Okay, proof. And let me just walk through how I try to solve this or prove this, okay? So I just started with the first term, like dn, which is dn 10 to the power of n. Okay, so I wrote it like this, okay, dn 10 to the power of n, and I wrote it like this. dn 10 to the power of n, 10 to the power of n is going to be 9 times 10 to the power of n minus 1 plus dot, 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 plus 9 times 10 to the power of 1 plus 9 times 10 to the power of 0, and then finally plus a number 1. Okay, so for example, n is equal to 3, right? Aside. Okay, let's say n is equal to 3. Okay, then what you have is 10 to the power of 3, which is equal to 1000. But this is equal to 9 times 10 to the power of 2 plus 9 times 10 to the power of 1 plus 9 times 10 to the power of 0, and then finally plus 1. So 999 plus 1. Okay, so 999 plus 1. Okay, and I do that for all of it. So dn 10 to the power of n. I do that for all of my my terms, okay? So we have d2, let's say d2, 10 squared is going to equal to d2. It's going to be 9 times 10 to the power of 1 plus 9 times 10 to the power of 0, and then plus 1. Okay, now I could write this in sigma form as well. So with dn, 10 to the power of n, this is dn, and then it's going to be 9, because all of these terms have a 9, factor of 9. So it will be 9, and then the sum from k equals to 0 to n minus 1, 10 to the power of k, finally, plus 1. For something like d2, 10 squared, okay, which is just 100 d2, this is equal to d2, and then 9 times the sum from k equals to 0 to 1, okay, if n is 2, n minus 1 is 1, okay, 10 to the power of k, and then plus 1. Okay, I'll do that for d1, 10 to the power of 1, which is just d1, and then it will be 9 sum k equals to 0 to 0 of 10 to the power of k. So this actually is just 10 to the power of 0, which is just 1. 9 and then plus 1. 9 plus 1 is 10. Okay, 9 plus 1 is 10. Finally, we have d0, 10 to the power of 0, and this is equal to d naught. Okay, and yeah, we cannot use a sum for this one. I mean, I guess I can, but that would be k equals to 0 to 0 minus 1, which is negative 1, and then if you use some sigma rules where the top index is smaller, it will be 0, but let me just leave it as d naught, like that. Okay, so we have all of these on the left-hand side. If I add them up, if I add everything up, then on the left-hand side, I'll actually just get n, all right? And on the right-hand side, I will also get n, but I will write it out like this. So I will have 9 dn. Okay, so I will take because each row has two terms, right? The sigma and then plus 1. Okay, the sigma and then plus 1. Okay, sigma and then plus 1. So what I'll do is I'll distribute the dn and the d's into these two terms. Okay, so I have 9 dn and then sum k equals to 0 to n minus 1, 10 to the power of k, plus dn, and then plus, and then it will be dot 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 9d2 sum k equals to 0 to 1, 10 to the power of k, plus d2 plus 9d1 sum k equals to 0 to 0, 10 to the power of k, plus d1, and then finally plus d0. Okay, now if I group up just the digits, the lonely digits, I'll have dn, I'll have a dn minus 1, I'll have, d3s, right, d2s, d1s, d0s. Those digits, okay, I can combine them. Okay, I will combine them to be the sum from k equals to 0 to n dk. Those are just the sum of all the digits, right? dn plus dn minus 1 plus dot 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 d1 plus d0, and then plus, and then I get these terms with the sigmas. So that will be plus. Now this is going to be very interesting here because I can factor out a 9. Okay, I can factor out a 9. So I have 9. Now, how would I write this out? Okay, because it seems to me that I have these sum. I have a sum of a sum. Okay, I have sum. I'll have a sum of sums. Right, these are sums. I have sums of sums of sigmas. Okay, now it seems to me that I have 9. 9 is a constant. I can pull it out of the sum. But what are we counting? You have d1, d2, d3s, dn minus 1s, dn's, right? So I could say that m goes from 1 to n, okay? The index counter m goes from 1 all the way to n. So m goes from 1 to n of dm, okay? Now, the rest, I can just look at this first term with a sigma. K goes from 0 to m minus 1, okay, of 10 to the power of k. All right, so m goes from 1 to n, and then k goes from 0 to m minus 1. Okay, all right, this is very cool. It looks something kind of like this. All right, so sums of sums. Now, of course, this dm I can multiply into here distribution, right? Because m is independent of k. However, m is not independent of m right here, so I cannot take the dm out, okay? I'm sure that those who dealt with sigma's rules know this. All right. Okay, so then now what I'll do is that, yeah, you know what? I'll just distribute this dm into this inner sigma right here. Why not? Okay, dm. Okay, so now I simply wrote n as this. Okay, that's all I did. I rewrote a number n using another form. So let's prove the theorem. Okay, so the forward part is going to be if 3 divides into the initial number n, then 3 divides into the sum of the digits. Okay, so the forward direction, we have 3 divides into n, which is actually just this huge number right over here. Not number, but this long expression. Okay, so it's equal to this. All right, so now what we have is that this implies, what does this imply? That n is a multiple of 3. Okay, n is a multiple of 3, call it 3 times r, where r is some other positive integer. Okay, oh, I guess n could also be 0. If n was equal to 0, capital N was equal to 0, it also holds, because yeah, if capital N was equal to 0, then your d, you just have a d0, or you can say all your d's are equal to 0, right? Because we have 0 right over here. So if 3 divides into 0, then 3 divides into 0 plus 0, or just 0. So you have, it doesn't matter how many zeros you have, the sum is 0. So 3 divides into 0 if and only if 3 divides into 0. But yeah, let's just say n is a positive integer, okay, a natural number. So r here would be a positive integer, natural number as well. So this means that n is equal to 3r, which is equal to, actually, you know what? I'll just do this. Yeah, 3r, and then I'll have to copy and paste this entire thing again. Actually, I will not do that. Let me write it like this. Okay, 3 divides into n, which implies that n is equal to 3 times r, which is actually this other way to write capital N. Now, this right here is 9 times this quantity, and this quantity is some other positive integer. Okay, so I'll call this to be 3 times q. Okay, because 9 is 3 times 3. Okay, and this part is going to be, I'll call it q. Okay, it's going to be a natural number, so 3q. So this implies that the sum right over here, if I isolate for the sum of the digits, k equals to 0 to n of dk, this is equal to n, or let me just write 3r minus 3q, which is equal to 3 times r minus q. Okay, and because my dk's are going to be non-negative, okay, my dk's are non-negative, then the sum is non-negative, so r minus q is going to be non-negative. But anyways, the point is r minus q is going to be some other integer, okay? This is going to be some other integer, and 3 times some other integer gives you the sum of the digits, okay? So this implies that 3 divides into the sum of the digits. All right, that's pretty cool. Now, the other direction is actually the trick that we use in school is that we first figure out if the sum of the digits is divisible by 3, right? 51, right? 5 plus 1, 6, divisible by 3. Therefore, the original 51, right? The original number is divisible by 3. Yeah, so the backwards direction is what we typically use for the division by 3 hack. All right, so we first have 3 being able to divide into the sum of the digits. Okay, so what does this mean? It means that the sum of the digits is a multiple of 3, so I'll call it 3 times some other integer t. And this implies that n, which is equal to the sum of the digits, which I call 3t, okay, plus, and then it's going to be this whole term, okay, it's going to be 3q, because this part is definitely divisible by 3, okay? So 3t plus 3q, and this is equal to 3 times t plus q. T plus q, right? Two integers added together gives you another integer. So therefore, right, 3 times some integer is equal to 3, which means 3 is a factor of n, which means that 3 divides into n, or n is divisible by 3. Great, and that completes the proof.